Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. I'm your host, Erik Bjornstad, and I'll be your guide through the ever-changing world of fuel. And it's time for another episode of the Fuel Pulse Show, Back to School. This time, we're going to talk about the ugly truth, why fuel stabilizers are one of the essential tools in your toolbox for taking care of stored fuel and making sure it's able to perform at its best when you need it to. That means covering things like what happens to fuel when it's stored, the best options to mitigate any problems that develop in storage, and how best to apply those options so your fuel gets the most out of them. First, let's address a question that comes from what we said a little earlier, this concept of the ugly truth. This ugly truth is petroleum fuels start to degrade from almost the start of their refined life. Now, when we say that, we don't mean they go from good to bad in a matter of weeks, but they all start out with reactive molecules as part of their composition. And these molecules look for other partners in the fuel to react with. This leads to chain chemical reactions developing in the fuel, where molecules react with other molecules and they link together, forming progressively longer and longer molecule chains. That is what gums and varnishes and deposits are. Now, even if you can minimize the fuel's exposure to things in the environment that tend to further degrade it, things like water, oxygen, heat, microbial byproducts, the fuel would still have these reactive molecular elements in them, slowly but surely degrading that fuel over the course of its life. When you find gums and varnishes, when you find the color of the fuel changing and darkening, those are all signs that these chemical reactions have been going on in the fuel. And that is the ugly truth. The fuel's condition will change over time, and there's not a lot you can do about it. Or is there? Well, the unugly truth is you can do something about this. The key tool you need in your fuel care arsenal that's best going to protect the overall quality of your stored fuel is a fuel stabilizer. Now, by definition, a stabilizer acts in different ways to stabilize or keep something from changing. That is what the concept of stability is, the ability to resist change. So a fuel stabilizer works to help a fuel resist change. In this case, resist change to its composition and to its essential properties. If you think about it, those chemical reactions that result in those sediments forming and the fuel's color changing, those are changes to the fuel's composition, to the fuel's condition. A stabilizer works to help the fuel resist those changes, so its composition and its condition and its properties stay the same. And that's ultimately what you want. You put the fuel in a storage tank so that it will be there for when you need to use it at some point in the future. And when you need to use it at that point in the future, you're hoping that it's going to be in the same good condition that it was in when it started out in there. Adding a fuel stabilizer is the key tool that's going to help make this hope a reality. So how does it do this? Without going into too much detail, a fuel stabilizer is going to be a package of ingredients formulated to act on the reactive elements in the fuel, as well as to act on the byproducts that they may have created. So it has ingredients to stop all the different kinds of chemical reactions, the oxidative reactions, hydrolysis reactions, that if left unchecked, would result in the fuel's condition changing in ways that you don't want it to. And it also will have active ingredients that act on those deposit molecules that may have formed to work to disperse them, to keep them away from each other, and also to suspend them throughout the volume of the fuel. Suspending and dispersing these deposits helps contribute to stabilizing the fuel's condition and keeping it from or slowing down its tendency to change. So the fuel stabilizer is the essential solution you're going to need to use. But how and when do you use it? How you use it is you add it at the recommended volume to the fuel. And the thing you want to do is you want to circulate the fuel to get that stabilizer well mixed into the fuel. the more completely the stabilizer is dispersed in the fuel, the better it's able to act on all those reactive molecules that are themselves also dispersed throughout the fuel's volume. Stabilizers need to be in proximity to those reactive elements in order to work. And it also means the best time to put a stabilizer in the fuel is as early in the fuel's life as possible, because the best way to stop a chain reaction is to stop the links in that chain as far up the chain as possible. That means as early in the fuel's life as possible. So the best practice for using fuel stabilizer is put it in when you get fresh fuel in the storage tank. Now, what about how often do you need to treat? Well, from a practical standpoint, you would plan to treat your fuel at least once a year. That's because stabilizer is not a one-time and you're done forever kind of thing. That stabilizer is going to be continually working, canceling out those chemical reactions, acting on the heavy molecules in the fuel. And as it does this, its chemistry gets used up. How quickly this happens depends on how reactive the fuel is. Now, the best way to tell whether this has happened is have an oxidative stability test run on the fuel. That test will give you a window into the likelihood that the fuel's condition is going to change for the worse at some point in the future. It doesn't tell you if you've got gums and varnishes and sediments in the fuel right now. The best way to do that is with a water and sediment test. But an oxidative stability test will predict, based on what's in the fuel right now, how easily or how likely that fuel is going to change condition in the future as it gets exposed to the oxygen and the environmental conditions that it's normally going to come across. And that's going to be your best confirmation whether you need to treat or retreat with stabilizer to stop this from happening, which is what's ultimately going to protect your stored fuel's essential quality. So to recap, stability is the concept of resisting change. Fuel stability refers to a fuel's ability to resist change in its essential properties. All fuel degrades over time because of the presence of reactive molecules. And that's over and above where it gets exposed to water and oxygen and heat and light and microbes, all of which will make that process actually happen faster. The essential tool to use to slow this down or keep this from happening is a chemical fuel stabilizer. You want to add that as early in the fuel's life as possible, and you want to make sure that it gets well mixed in. Although all fuels are different, the general recommendation is you should expect to retreat with stabilizer each year. If you need a more quantified idea of whether your fuel needs to be treated or retreated, have an oxidative stability test run on it. And so that's going to do it for today's Fuel Pulse Show Back to School quick dive into the issue of fuel stabilizers. If you liked what you heard and you haven't done so already, feel free to subscribe to us at your podcast platform of choice, whether that's iTunes or Stitcher or Google Podcasts or wherever you happen to like to listen. And leave us a review if you can, because that really helps other people find us. So until next time, I am Erik Bjornstad, thanking you for joining us, and we'll see you next time for the next episode of the Fuel Pulse Show podcast.